Hello, we are here to review the metric system, and I'm going to talk about it specifically within the context of being a nurse and needing to do unit conversions, usually for dosage calculations, but sometimes also for your charting if you're weighing a patient or measuring a wound or something to that extent. So let's just review the different ways that things are measured. We can measure the weight of something. This can be the weight of a patient. Now, typically, if we're weighing a patient, we're using a scale, and if this is an adult patient, it might show us the weight in pounds. The pounds is not the metric system. Kilograms is the metric system. So you can just see here, I have weight, and that is grams, all right? But often with adult humans, they're big enough that we represent them with kilograms. Kilo means 1,000. So 1,000 grams is actually 1 kilogram. Now, we also have grams that's often used in for babies when you're measuring them, but also it can be used for some medications. Typically in medications, we're using milligrams and or micrograms. So that's the actual weight of like the active ingredient or however they're measuring it. But as nurses, we're not like getting a scale out and weighing our medications usually. We're determining how many tablets or capsules or milliliters to give that patient. So we'll need to know, okay, how many milligrams are in this tablet or how many milligrams are in 5 milliliters. So you'll learn that as you go throughout. That's part of what dosage calculations is determining what to give. Let's move on to talking about volume. Volume is represented in liters in the metric system. Now, typically we are not giving a patient a whole liter of medication unless it is an IV bag, which is the most common thing that I can think of. A typical IV bag that you stereotypically think of is a 1 liter bag of fluid. But medications that were taken orally are often given in milliliters. 1,000 milliliters is equal to 1 liter. So that liter bag is also could be called 1,000 milliliters. And I think this brings up a really good point. And I like to draw a bottle of like soda, whatever you'd call it, soda pop, whatever you call it, a bottle there. Or here we have our IV bag and we have the needle going into it and the tubing going to the patient. This could be represented by saying 1 liter, or you could also say this is 1,000 milliliters. If I say this is 1,000 milliliters, is the same amount of liquid in that bag as if I say 1 liter? Yes, unless it's emptied out in between those two statements, and that would be a different amount of milliliters. So when we're talking about unit conversions, we're not talking about changing the amount of volume in something. We're just representing it with different language. We're saying milliliters instead of liters. So remember that as you're doing your conversions, you're not actually changing the substance, you're just changing the way that you're talking about it. All right? Same as your soda pop bottle. If you had a bottle of Coke or Pepsi or some other brand name, if it was a whole liter in there, and you could also say it was 1,000 milliliters. Maybe it's 750 milliliters. So you could say 0.75 liters. Those are the same things. And you can do unit conversions to determine how many liters equal how many milliliters in this bottle or whatever. All right, moving on to meters. Now, I've never used meters in my nursing experience. I've used kilometers in running because that's quite a far distance. I've never used meters to describe someone's height, but I have used centimeters to describe someone's height. I've also used centimeters to describe wounds, or you may have used millimeters, which are even smaller. So typically when we're talking about the length or the width or the depth of something, we're going to use this centimeter, millimeter language. Now, unit conversions for dosage calculations are going to be focused on those milligrams to milliliters usually, or milligrams to tablets. So we'll do an example with that. But on the next slide, I'm just going to show you how to convert from one unit of measure to another, and I'm going to use the example of liters to milliliters first. So let's just say that we have 750 milliliters, but I want to determine how many liters is that. I can use dimensional analysis to do this, or the unit factor method. There's also several other ways to calculate this change within the metric system. You can move the decimal 3 places, or you can divide or multiply by 1,000. So those are the 3 basic methods. A unit conversion method, like dimensional analysis. You can move the decimal 3 places to the right or the left, or you can multiply or divide by 1,000. I'm going to show you the dimensional analysis method because it's very similar to multiplying or dividing by 1,000. So let's figure out what we have to start with here. We know we have 750 milliliters. Now I'm going to tell you our conversion factor. We know that 1 liter, because we've hopefully memorized it or we can look it up, 1 liter is equal to 1,000 milliliters. This is what we can call our conversion factor. We know this is always true. All right, we use our conversion factor to determine how many liters are in 750 milliliters. So I take what I'm starting with, 750 milliliters, and I multiply it by my conversion factor. If you watched my intro to dimensional analysis, this might look familiar. We know we have to put the 1,000 milliliters on the bottom because milliliters is in the top on the first part of the equation. So we put 1,000 milliliters on the bottom, and we know that equals 1 liter. 1 liter can be up here. I'll write out liter just to be clear. All right. Now, when I look at this, I can also just double check by making sure the numerator that's labeled here in milliliters cancels out the denominator that's labeled here in milliliters. And once I've done that, I know, okay, my final answer is going to be in liters. So let's go ahead and do the math. 750 times 1 is 750. We then can divide by the bottom, which is 1,000. So we have 750 on the top, and then it's just nothing, or 1 times 1,000 on the bottom. And that is going to equal 0.75 liters. So there you go. 750 milliliters equals 0.75 liters. Setting it up with dimensional analysis can help you see why the formula works. If you know you're going from a smaller unit of measure like milliliters to a larger unit like liters, you know that you can just take 750 milliliters and you can take this decimal that would be there, or assume, you could imagine it's there. You don't have to put it there, but it's there. And you can move it 3 spots to the left. So now the new place for the decimal is there. You have to put a 0 there too. But that's where you get your 0.75 liters too. So that's the other method, moving the 0 3 places to the left. The other option is the divide by 1,000, which is what we did up here. If you look at that part is showing how that method works, the multiplier divide method. So some students, when they're doing these different methods, it takes a little practice at first if they haven't used the metric system in a while. So don't be kind to yourself, practice a lot. Decide which method works best. A lot of students that are using a calculator tend to use that divide or multiply by 1,000, but making sure you can set it up with dimensional analysis helps you really know you have the concept understanding of why you divide or why you multiply by 1,000. Let's do another example in which we go from grams to milligrams. So let's say we have an order to give a patient 1.25 grams of a medication. But we only have it available to us in however many milligrams. So we really don't know how many we need to give to that patient. So this unit conversion is going to be important for determining how many tablets or how many milliliters we're going to give that patient. Now let's review our conversion factors. We know that 1 gram equals 1,000 milligrams. So that's our conversion factor. We'll go ahead and start right out with our dimensional analysis. We have 1.25 grams that we are trying to figure out how many milligrams it equals. So we can multiply it by our version of 1 or our conversion factor. What number goes in the bottom? Look up here at your conversion factor. We know that 1 gram goes on the bottom because the grams is in the top, the numerator on the beginning of the equation. And then we have 1,000 milligrams. You can always double check these by making sure you look there and say grams are in the top, grams are in the bottom. Now you still have to use those numbers in the math. So we'll take 1.25 and multiply it by 1,000. If you're doing the decimal method, you're moving that decimal point 3 places to the left. So you got 1,250, and that's over 1, which is equal to the same thing, 1,250 milligrams. So we have to give our patient 1,250 milligrams. That's one way to say it, or we could say they need 1.25 grams. I'll demonstrate this move the decimal method quickly in an example down here in blue. So we have 1.25 grams. If I'm going to move the decimal, I'm going from grams to milligrams. So I'm going to a smaller unit of measure. Milligrams are smaller than grams. So I'm going to move it to the right then, and I'm going to move it 3 places. 1, 2, 3. I would have to put a 0 there, so that's my new decimal spot. So I know that 1,250 milligrams is my final answer. You can see how moving the decimal can be confusing. If you don't move it the right way, you end up with the wrong answer by a lot. So be careful if you do choose this method that you do it correctly. Just like multiplying and dividing by 1,000, make sure you don't do the opposite because you'll end up with a completely wrong answer. And you could really, if that happened in the patient care setting, it could be devastating to your patient because it would be so significantly wrong in the dosage. If you need more practice, look up examples on ways to practice your unit conversions in the metric system. Unit conversions are really important for a lot of dosage calculations, so you'll want to be pretty proficient at this skill.